Hello, this is Patrick at OneCNC West, and what we're going to do in this training video is continue to apply toolpath to our part geometry. Now, what we're going to do is we're going to focus on drilling the 8 holes on the face of the part. This is going to require C-axis live tooling machining. Now, this is very easy to do, but there's one thing I noticed in between videos that I think we need to take care of. I'm going to hit the spacebar twice to quickly go to a CAD view, and I'm going to turn the subspindle layer off and turn the main spindle layer back on so we can actually see the geometry for the main spindle. If we take a look at this roughing operation for main spindle, you'll notice that the toolpath goes past this diameter right here. You can see how it goes all the way past. So this area has already been machined. If I were to turn that layer off, turn our subspindle layer on, and take a look at the roughing we did here, notice how we've also machined the same area. This area has already been machined when we were performing the toolpath for the main spindle. So how can we edit this? Well, we can simply do that by heading over to the NC Manager. We're going to right-hand mouse click on the roughing operation and select Repick Path. From there, I'm going to reselect the geometry that we want to apply the roughing to. I'm going to left click here. I want to choose this arrow to be on that side of the geometry, and the direction looks good. But now, instead of coming all the way over here to the left, I want to stop right here just with the left click, and when I'm done, I can right-hand mouse click. And that way, OneCNC is only machining the area that needs to be machined. All right, very good. Now that we've taken care of that, let's take a look at creating the geometry for these 8 holes. For good housekeeping, I think we should create a layer for this. So I'm going to head down to the layer browser. I'm going to right-hand mouse click and select Add a Layer. Now this is something you don't have to do. Again, I think this is just good housekeeping. For the layer, let's rename this by double-clicking on the layer name. And why don't we call this 8 holes on face? That looks good, so I'll click OK to that. Now, with this layer selected, let's create the geometry. Let's head over to the Command Manager. From there, let's go into Model Tools, and let's select this option called Extract Surface Edges. This is really the fastest way to go. Let me demonstrate. We're going to select Extract Surface Edges. I'm going to take my cursor and just left-click that surface, and once we do that, OneCNC has created geometry on that surface. So if we were to turn the other layer off, you can see the geometry that's been created. Let me show you another technique. I'm going to hit Control Z on the keyboard to undo that. I'm going to make sure I have that layer selected. I'm going to turn our subspindle layer back on. Now, if you'd like to create less geometry, you can still use your model tools, but this time, instead of using Extract Surface Edges, you can use Extract an Edge. And that way you can come in here and just left click each one of these holes independently, just by left clicking on the edge at the outmost end of the hole. And when you're done, you can right hand mouse click. So now if I turn that layer off, you can see that we just have the 8 holes. Either way will work perfectly for you. Now let's say that you have forgotten the diameter and the depth of all of these holes. Well, there's a very easy way to confirm the dimensions that we're looking for by heading over to the lower right-hand corner, going into our Verify option, and from there select the very first option, which is called Retrieve Information About a Single Entity. I can now take my cursor and just left-click on any one of these edges, and OneCNC tells us that the diameter is 375 thousandths. Now, what about the depth of these holes? Well, we can measure it in a couple of ways, but let me show you another tool that's very powerful within the Verify suite of tools. It's the option here called Retrieve a Distance. This works just like a ruler. I'm going to left click that. I'm going to zoom in just a little bit. I'm going to left click the bottom vertice of the hole and then left click the top vertice of the hole. And now OneCNC reports that the length is 625 thousandths. With that information, we could rename our layer if we want to. Instead of it saying 8 holes on face, let's rename this by double clicking. And why don't we call this 0.625 thousandths deep by 375 thousandths diameter holes. Very good. All right, so now let's apply the toolpath. To do that, all we need to do is first head up to the upper right-hand corner and make sure that within your multi-axis machining tab, you have the Z-axis face option selected, and also for the face Z value, make sure you have the default value of 0. That simply means that the face of the part is indeed at Z0. We'll click OK to that. Now let's head over to the Command Manager, and this time, instead of selecting Lathe Toolpaths, let's select Model Toolpaths. These are all the toolpaths that we can use for standard live tooling Z-axis machining. Now, there's two types of drill machining operations that we can select from. There's the Hole Wizard or Drill Single. Hole Wizard's going to interrogate all the holes of the part and gives us the ability to apply multiple hole operations. We can do this much more simple by using just the Drill Single command. Drill Single doesn't mean you can only drill one single hole. It just means that you can only apply one hole operation to the hole or group of holes that you selected. So I think this will work great. I'm going to left-click Drill Single, and once we do that, we have this menu where we can decide how we want to select the holes. I'm going to use this option called Arc Center, and all I'm going to do is take my cursor and I'm going to left-click those arc centers in the order that I'd like to drill them. Just by moving the cursor to the arc center, wait till you see that little square left click, and when you're finished, just right-hand mouse click to tell OneCNC that you're finished selecting the geometry. With the geometry selected, we can click on the Finish button, and now it's time to define a tool. Now, unlike lathe machining operations, when performing a mill or live tooling machining operation, you can actually define the tool right here without selecting the tool from the tool library. Now let's place this tool in turret position number 5. Let's give it a spindle speed or RPM of 5500, a feed rate of 20 inches per minute. Now for the holder, I've selected a 0.5 inch side lock. For the tool type, we're using a drill. The overall length, that's how far the tool sticks out of the holder. I have 1.5 inches. And for the flute length, I have 1 inch 250 thousandths. It should be noted that this is all very dynamic in regards to graphics. If I were to type in 2 inches for the overall length, notice how the graphics over here on the left change. It's very nice to have that type of feedback when entering the parameters. Same holds true for the tool holder as well. You can select different types of tool holders, and OneCNC will give you a nice graphic preview before you click OK. For diameter, we have 375 thousandths. Again, this is all dynamic. So if I were to type in 0.5 or ½ inch, you'll see the graphics update as well. Let's put that back to 375 thousandths. Included angle, 118 degrees. I think that looks good. Let's click Next on that. Now for clearances and depths, this is where we can set up all the valuable information regarding the Z-axis when we're actually performing the drill operation. Rapid Z-plane, that's represented by the red grid, and that's going to be the Z level that the tool is going to use as it moves from hole location to hole location. This is also dynamic, so if I were to type in 1 inch here, you'll see that red grid hop up to 1 inch. Let's put that back to 1/2 inch, just like that. Plunge clearance, that's represented by the little black corners. That's where the tool is going to start to feed down. I have 50 thousandths. Material Z-top, that's of course going to be 0. That's the same Z level as the face of the part here. And then for final Z-depth, I have -625 thousandths. Now down here under options, you have two different things you can select. You have machine cycles and you have automatic cycles. Machine cycles is if your control supports canned cycles. For example, things like G81, G82, G83, and so on. Automatic custom means that your control does not have the ability to accept canned cycles, and the G code is going to be output in a long style format. In other words, lots of rapids and feed moves to perform the drill operation. It should also be noted that you're going to get a different menu depending on what you select here. If I select machine cycles, Notice we have the next menu giving us the ability to select the can cycle. However, if I select automatic custom, this menu is completely different. All right, let's click back. Let's use a can cycle for this. We're going to click next on that. I'm going to use a G83 deep hole drilling cycle. And for the peck amount, I'm going to put in 200 thousandths. I think that looks good. So let's click finish and let OneCNC generate the toolpath. Very good. Now, why don't we end this video by doing a quick toolpath simulation? To do that, I'm going to right-hand mouse click on the toolpath group, and I'm going to select Simulate Rest. Now for the stock, we're just going to use the option called Round Bar, but later on in a future video, I'll show you how to use a solid model for the stock. For now, we're just going to use Round Bar. I'm going to say the stock diameter is 6 inches 300 thousandths. One end of the stock's at -5 inches. The other end of the stock we'll say is at 50 thousandths. We'll click OK and let OneCNC simulate the toolpath. All right, so we're looking at the roughing operation here. We can rotate this around if we want to. After that, we're going to perform a profile or finish operation. We're going to see that in just a second. We'll switch tools. There we go. We've got a finish tool. There's our finish pass. And then now we're performing the facing, the drilling at the center. Here's the chamfer. And now we're going to select that 3/8 diameter drill and perform our live tooling or our C-axis. We can speed the simulation up by moving the little slider in the lower left-hand corner a little bit to the right. And of course, while all this is taking place, you can rotate, zoom in, and zoom out. Very, very nice. All right, that's it for this training video. Thank you so much for watching, and I look forward to seeing you in the next video.